Hate recording. Hey there guys, Nate's Not the King here, and yes, I am back today for another video. Why? I don't know. It's Nate's Not the King because I'll never be the king, even though my last name is King. Still weird getting used to this room. Anyway, so guys, today I'll be talking to you about a topic I've been recently very excited for. And I hope you guys are very excited for me to talk about this. Meiosis! Everyone loves meiosis! Oh, the way that the sperm sex cells just multiply. Reminds me of the good old times. What is meiosis? Is it just sperm being made again? How does it work? Why does it work? How do we get genetic variation? This is questions I never thought to ask. These are questions I'm ready to ask myself and see if I know the knowledge and bring you guys along with me. Now, if you guys aren't excited for this video and you don't know why I'm making this video, I don't know why either. Again, it felt like something I needed to do. Let's get into this, and I think it will be very interesting. I think you guys will enjoy it. And also, I broke my arm. Assessed it myself, and I found some sort of swing in this room, and I just put it on, and look at me. Look at me, I'm all brand new, hitched up. To first start talking about meiosis, let's talk about what other people think about when they first hear the word meiosis is mitosis. Mitosis is the process that just copies one of your cells and splits it into twos, and they're equal. They're the equal amount of number of chromosomes, equal amount of DNA. They're the same exact copy. They're daughter cell, mother cell. And when we talk about meiosis, it follows a similar path, where it will split into two, but those two will be split again. So it doubles the amount of splits it does. So meiosis splits twice, where only mitosis will split once.
Meiosis. Well, I think I kind of flunked out of school to know that.
Yeah, well, meiosis is basically division of a cell after going through interphase, which interphase, you know what that does, right?
I mean, yeah, they tween together and make...
No, that's prophase!
Ah, dang it.
No, they double, dude.
Ah, jeez.
In mitosis, it is a diploid cell. Diploid is the word we use to describe the amount of chromosomes it has, where haploid sounds like half, so it's half the amount of diploid. So haploid is what happens when we get from meiosis, and a diploid is what we want to get from mitosis. So diploid, it starts at diploid and then ends diploid in mitosis, and in meiosis it starts as diploid and then ends as haploid. And the amount is like, we describe it as 2n, that's diploid, and then haploid would be half of that, so it would be n. Chromosomes are what are made, that are used in meiosis and mitosis. That's what we're trying to make sure we can bring to more cells. That's the genetic information. You know, DNA strands, different alleles that code for your who you are. Like if you got brown or black hair, it's that. And that's also, we'll talk more about why the alleles are important when I talk about genetic variation, but the alleles are what help code is mostly what helps code the whole body, and it's made of every chromosome. And there's multiple alleles on top of a chromosome. The reason why we want two haploid cells in meiosis is so when we bring them together, we can make one diploid cell that we can then use mitosis to reproduce and have more and more and more cells like that. What is the cell life cycle? It starts in meiosis, and then fertilization of the egg. Gametes are the sex cells, which are sperm and the egg. And when two gametes come together, they make a zygote. And then it goes back to, then you have a whole new person, and then this person mates with another person, and then the list goes on and on. That's the circle of life. There you go. Polyploids, those are just like 3N, 4N. We're not really going to care about those. I know that there's going to be comments that in the future, if I ever get comments that matters, they're going to be like, what about the polyploid? I'm going to be like, ew, well, polyploid doesn't happen in human cells. As if it did, it would kind of kill us. It already makes you a little bit down if you have an extra chromosome, if you know what I mean. That's basically what you're eating at stores. They're polyploid fruits and vegetables. Vegetable. Yeah, I guess vegetables. Potato is a vegetable. It's different in animals than it is in plants, you know. It happens a lot earlier for plants. Plants do go through meiosis, but they don't make like sperm vagina cells. Mitosis, it happens in like a quarter of a pie, is like most of mitosis, and then meiosis. Because meiosis is only a small portion of people's lives. But meiosis is one of the most important things. But it does happen later on in people's lives too. Like later when they get older, they get 14, you know, you start getting puberty, you start making sex cells, and you start getting pheromones and hormones and all these types of things. And what happens is your body is now making those things, and you could actually just keep the circle of life going. I mean, have that kid when you're 13, why don't you? I mean, I did. We all know the classic PMAT of mitosis. What about, it's the Diploid PMAT. Well, let's get to it. So, we all know interphase. This happens once in every cell. And no matter what we're talking about, mitosis and meiosis, interphase happens once. And when interphase happens, that's the doubling of the chromosomes. And that's how you say we get, you know, when we start mitosis, we can end at 48. Because the numbers double, right? They also thicken, and then the
nuclei, I don't want to say this wrong, it's the outer, right where the chromosomes are at, it starts to break apart. Nucleolus? I think it's nucleolus, I'll look it up. I'll put it here, right here. I can't see it right now, but it's on my notes, but I know it's somewhere right here. I'll put it right here.
Cool bros here. Oh my god, what are you guys doing?
We're just doing some family-friendly things.
This isn't family-friendly at all. You are talking about sperm. You know how sperm is? That is not advertiser-friendly.
You know that is meiosis, right? That's what we're talking about.
Meiosis, musmosis. Your channel is going to get taken down if you're not more family-friendly. You got that?
You didn't do anything.
You totally did. Don't make me take this YouTube video off. I will ban your channel for 30 days. Also, buy a 30-day trial. But that's a whole different story, okay? Make it user-friendly.
Break apart. And spindle fibers are also being formed, the centromeres. And in the centromere, on the spindle fibers, there are these motor proteins that help it push it out. When it pushes out, that's the part where it gets it. So in prophase, it's starting to push out. And then what happens in prometaphase, which is a phase which people don't really know, it's the in-between of prophase 1 and metaphase 1. And right between when the chromosomes are being aligned up in the middle of the axis and right before the spindle fibers attach. When they align at the middle axis, that's metaphase. And in metaphase 1, the spindle fibers connect to they just connect and they pull apart homologous chromosome pairs. They don't pull apart, right, like in mitosis first. They don't pull apart the pairs. They don't pull apart the homologous chromosome. They pull apart the pairs. And so and if you think about it, our cells at anaphase 1, when it's being pulled apart, they're going to become 2 haploid cells. Because even though the number doubled, you still are at haploid when you're putting half of them. Even though the cells being split and it's going to be haploid at the end, they're just homologous chromosomes, so it still counts them as being haploid because there's less numbers. So when they're split like this, they're still haploid, but they just are the same number. When they go into telophase 1, they start to close in, which causes a cleavage furrow, which pulls the cells apart, bringing them 2 separate cells. And now with those 2 separate cells, they're going to go form another separation. Prophase 2, they're going to start to break down that nucleolus, I think, and they start to line up again at the middle in the metaphase 2. Then spindle fibers, they hook onto inside the chroma 10. There's a chromo. All the words go together. There's so many chromo words. So the spindle fibers connect to the middle part of the. So on a chromosome, it goes into that and it pulls apart the 2 homologous chromosomes. And when those chromosomes, I'm pretty sure that word's a chromatid. So the spindle fibers hook onto the centromere, and at the centromere it will pull apart the sister chromatids. And I was right, each single one is a chromatid. So chromatid, it will pull apart the chromatids, and where they will be now in the separate cells. And then in mitosis, when they come together, they're gonna fertilize and then bring 2 haploid cells to a diploid cell. Explain. It's all there, it's all done, it's all said and done. So how does the cells have genetic variation if they're still, like, how am I getting a variated version of a chromosome, of the chromosomes, if they're still kind of the same? So in the S phase, and I got a whole pie chart right here, I'll just show you. In the S phase of right before it starts meiosis, it's already, doubled. It's going to double its amount of chromosomes. And why do they do this? Why do we need to double chromosomes? Why bother doing the replication? Why does it happen? Well, in the S phase, which I'll show right here, in the S phase, right before interphase, the S phase of interphase, it will double its chromosomes, just like mitosis. We only want to separate the first time the homologous pairs. Like I said, we want to pull them apart. We don't want a chromatid yet. We don't want to do that, or we will have haploid cells. We know that. But what happens, a very interesting thing that happens in prophase 1 is the synapsis, which, if you don't know that, but I would just say crossing over. The crossing over of the 2 homologous chromosome pairs, they will cross over. And I could also get into data linking, where you can see if 2 alleles are linked in any way, or if they're all connected by when they happen in interphase, the synapsis of the chromatid. I can get into all of that, but I'd rather just stick on the meiosis train today and not try to bore my whole audience for the next 3 hours. So I'll just keep talking about meiosis. Synapsis is the getting together, pairing up of homologous chromosomes. So when it's paired up onto into the equator, it will be together, and then tetrad, or 4 sister chromatids, which is how many we have in at the beginning. They're all lined down in the right there in the equator. Then crossing over happens at the Chismasta. Can I say that again? Chiasamata. That's the word. Those are fun biology words. You always know they're the fun biology words when they're hard to pronounce. What about the snurps? I love the snurps. I forgot to say something about my favorite thing. I didn't mention it. I didn't mention my favorite part, which is cytokinesis. Well, I didn't mention it. I said cleavage furrow, but I didn't say the word because I love the word. Cytokinesis? It sounds like some magic we do every day, but every day after you're old enough, you're doing cytokinesis, guys. I got magic skills. Yes! Meiosis 2 is the division of the division bell. There were some thoughts that strayed constantly. Meiosis 2 is the division of the sister chromatids. So what are the values of sexual reproduction? Because you could just be an asexual reproductor, and you could just go about your day just making babies without no one else to help you. Or you can have genetic recombination. Like, you know, in metaphase, when they align, it's always random where they align with the chromosome pairs. It's always weird. How would you know where they would line up? How could you do that? Because it's random. It's a random assortment. It's just where they want to align, where they feel like it. I don't know, maybe I feel like a middle today. Maybe I feel like a top. And then there's crossing over, which I've talked about, and random fertilization, which sperm picks to be in the egg. This is the driving cause for evolution. Evolution! It's magical! When the sperm gets inside, there's a bunch of them. They're all heading towards an egg. And as soon as one sperm penetrates that egg, it's that sperm's area now. Though, now without its benefits, or would it be benefits, or you don't have a tail anymore? I mean, that sperm doesn't have a tail. As soon as it gets in, the tail cut right off. And it's basically like kind of a force field. There's this cool video I've seen before where it's like, you could see where one sperm hits it and it's like, chunk chunk, all of them just die. Each ejaculation, 100 million sperm. Spermatogenesis, continuous and prolific process. 250,000 sperm produced per day. Each ejaculation 100 to 600 million sperm. And women only get to produce 2 eggs. I don't believe this shit. So what is made of sperm? What is a sperm thing? There's a cell membrane, right? And then you have, right in the tip, is a chromosomal vesicle. Which vesicles are things that can contain food, water. It's a transport thing. There's a nucleus in there, a centriole, mitochondria, and exonyma. Exonymy? Anyway, yeah. And then right at the tail, that is just some flagella. I mean, go ahead with, what else is there? So what I just explained was the making a sperm. That was sperm. Let's talk about women. Mostly their vaginas. Let's talk about eggs and ovaries. So they halt before anaphase 1. So meiosis 1 is completed before fertilization. Before that. And then meiosis 2 comes along and happens after fertilization. The first time it splits, you make a first polar body, and you go from 2N of an ogunum to a primary octum, an octite, and that turns into a split of a first polar body and one egg. It makes one egg. And then ovulation happens after fertilization. The entry of the sperm triggers completion of meiosis 2. When the sperm comes into the egg, it makes a kind of a chemical reaction that triggers the cell to know we have something come in, and so that's when the shield goes on. It's pretty cool. So then this is where they cross over and they start to trade information.
Like what types of information?
You know, like if you, like they from a mom cell, the dad cell, a dad chromosome.
What about a dog cell, man?
I don't know, dude. Anyway, and then you go to metaphase when they all start to line up in the center. Of course, they're still crossed.
Oh boy, they're both cross-eyed?
Whatever. And they line across the equator. And then in anaphase, the spindle fibers, or whatever you want to call them, start to grab the chromosome and pull apart. And then telophase, cytokinesis happens and it pulls apart, and that's meiosis. To mention in meiosis 2, that makes a second polar bodies. So the acrosome that was in that vesicle I talked about in the sperm, when the sperm hits the, since it is a cell membrane, it will just go in and it can just, all the aculates can just go in and it will make a little thing. And then there's a fused plasma membrane that will also enter and go where it will want. And it will just like set off kind of a reaction. It will fast block to polyspermy, from egg to zygote, which is when it's fertilized, and then to morula, which sounds awesome. We were born with tails. We were all born with tails. You got a tail, I got a tail, I got webbed fingers too. I bet you got webbed fingers too. They just, disappear. We look like whales when we're born, like when we're in the womb. It's kind of cool. I think that all of the beginning of life is just an interesting thing to think about. Humans develop fast compared to most things that are big like us. Like we're big, we have smarts, we are top of the food chain. I'm top of the food chain. One more thing. How does the lineup work? How do we even know what cells would go into what sperm? Like, where would it go? How do we get what does it look like when the mom cell comes with the dad cell? Is there a way we can figure out types we can have? Like with blood, how are we gonna know what our kid's gonna have, what blood they're gonna have? Well, Mendel was the first person to try to look into this. He made the classic experiment everyone knows. The 4 flowers that he found, peas. The 4 flowers he breed. Let's just start with them easy. 4 flowers he bred together. They came together and they bred. They gave him the same color. F1 generation, sorry. So in the pea generation, which is the parent generation, that he bred a true breeding white and a true breeding purple. And what happened when they came together was they made purple. And he was like, wait, how did they all turn out to people? So he self-pollinated, like incest. He self-pollinated and he observed what happened with the F2 generation. 25% were purple and 25% were white. He's confused. How did this happen? How did he breed something that all turned 100, all were purple, but came again, white, one white? And then he thought, what if they're still hidden? They're hidden. So the thing is, when you get the sex cells and they come together, One comes with a dad, like if it's going to come on and off, if it's dominant or recessive. So if dad comes in with a dominant allele, and mom came in with a recessive, wouldn't all of his kids have dominant recessive? And if you think about dominant is to be over something. So we're gonna be dominant over recessive. If we have two recessive genes, then there we go. The kid's gonna be, and since the parent only gives one of them, we can make a little square out of this. And so you can figure out, and you can just gene map anything if you want. You can figure out if your kid could have brown, white, black hair, white hair, just a normal white hair. I always had the white hair. So you could have a genetic variation of kids, and that's how it really works. I mean, you bring together two parent things, and then they code for future kids. So why did I care about this? I don't know. Did Austin care? The sperm has 23, the egg has 23, and when they come together,
they make them thing.
But how many chromosomes are in that?
46.
Yes. That makes a baby because 46 is a human, is how much chromosomes are in a human. And then, I think, intern. Yep, and then all of that makes meiosis.
And that what makes that girl look not so hot anymore.
No, I think she's just a man. The man.
Hide me from that man!
Anyway, I guess that's meiosis. Or am I still continuing this video? I don't know. So, this was just Nate's not the king. I will never be the king again, even though my last name is King. Never to be zero, always to be the one.